To do a polynomial with you guys, and I'm hoping we can finish it. Yeah.
Huh?
One problem.
Oh, no, I'm talking about the one.
Oh, this is gonna be a lot more. So what your homework packet doesn't have is polynomials. Your homework packet has a couple rational ones. It has a combination ones that I think have square roots in them. There's nothing wrong with those, but in terms of trying to do the derivative tests and finding all sorts of answers, a polynomial is much easier on some things and much harder on others. So that's why I want to pick one of these. Not to mention, I'm pretty much guaranteed you're gonna have a polynomial on the test, so I want to make sure you have one to practice. And if you want more to practice, you pretty much can always just make up your own polynomials and then try them. Or go to the textbook, which has a ton of stuff. Okay, I have my graph on the next page, so this page we'll just dedicate to finding all sorts of answers and whatever. Aaliyah? Do you remember where we start? Like, what's the first thing we're supposed to find? Okay, good. Find the zeros. Oh boy. Donald,
Yes, sir.
why is finding the zeros really hard?
Because it is it's a fourth function, it's to the fourth power.
Yeah.
And it doesn't have a constant.
Kinda does, but yeah, you're right.
Oh, yeah.
Yep. Okay, so usually our method for trying to find answers on polynomial is factoring. So I'm guessing you can come up with the first factor pretty easy.
Is it just zero?
Yeah, correct. Zero will be the number answer, but factor out an x. Okay. Partway. Emily, where do I go from there?
I give you some extra.
Yeah, unfortunately, that was pretty good. I was wondering how long it was gonna take us to come up with that. So, unless it's a perfect cube,
Nice one. Nice one. You proud of you too?
I don't even know where to go with that.
What happened?
You record.
So unless it's a perfect cube, you're not gonna be able to just like come up with the answer. And so the most efficient way to do it is with synthetic division, not by looking at your calculator and coming up with the answer. So you have to come up with the factors of 64 divided by the factors of 1. Those are all the possible choices, which is a lot. So I will tell you one of them right away to start with, so that we don't have to try 500 numbers to come up with them.
Could you factor that by grouping as well?
Ooh, it might work, wouldn't it?
That's the way I was taught to do cubes.
So you 100% can try that when there's 4 terms. And, oh, no, not gonna work. Mainly because this one is in the ratio of 1 and 12, that's not 1 and 12. And if we swap 2 of them, it'd be 1 and 4, or 1 and 48. So factor by grouping would only work if they have the same ratio between the first 2 numbers and second 2 numbers. So you could try it, it just wouldn't come up with the right answer.
Okay.
So synthetic division is just going to be a different method. So we're gonna write down 1, negative 12, 48. I'll just erase these when I'm done, but negative 64, Now, if I remember right, I think 4 was one of the correct zeros, so I guess we'll find out. Otherwise, you basically would just sit there and try all the factors of 64, which would take a long time. I mean, if I had no clue as to the answers, I would probably try 8 first, just because 8 and 8 is 64, and I usually try the middle numbers. But I also know that I'm gonna have 3 factors multiplied together to get 64, so it's probably gonna be a smaller number. So we'll try 4. So bring the 1 down, multiply, add, multiply, add, multiply, and if your remainder is 0, then that means this is one of the zeros. It does not mean this is the factor, it means it's a 0. So, right away, I know one of the factors is x minus 4. Now, to come up with the other 2 factors is the answer from synthetic division. This is gonna be 1x squared minus 8x plus 16. And that one we can factor. Minus 4, which gives us 2 more of the exact same factor. Okay, so we have x and then 3 factors of x minus 4. Can I erase the synthetic division one?
Yeah.
I just didn't know if anybody needed it for their notes or whatever, okay. Ooh, does it get bigger? Oh, whoa, that really got bigger. What is it doing? Something tells me these smart boards are not gonna make it 10 years. Yeah, go ahead.
I just had a question. Are we gonna have to do synthetic division on the test? Cool.
Haven't even made the problems yet. It's always an option. I mean, if you can solve it with a different way, that's fine. If you can solve it with synthetic division, that's fine. I mean, like, usually there's multiple ways to try to find an answer. This one we had to just because of the higher power. Okay, so this found us the x-intercepts. So we basically found our first answer after 5-ish minutes. And we've only got like 20 more to go. X-intercepts of 0, 0, and 4, 0. So first thing I would do on my graph is I'm gonna go put those 2 points on my graph. 0, 0, 4, 0.
I don't have a graph.
I would use another sheet of paper for your graph. What did I say, 4? Yeah. Now, since you guys probably haven't made a graph yet, I'll just tell you that the width of your graph doesn't need to be super wide because that's how the wider it's really gonna be. You wanna make sure yours goes down to 25 or 30. Okay, found the first thing. Izzy, how do we find the second thing? So I've got the list over here. So next we're on y-intercepts. Absolutely. You're gonna put 0 in place of x, and you're gonna find the answer is 0, 0. And we technically already knew the answer, just because 0, 0 was an x-intercept and a, like it's both. But yeah, you put 0 in place of x to find the answer. Okay, good. Now we are on vertical asymptotes. Sophia, you remember how to find vertical asymptotes? 100% they are. So this one doesn't have one. So you can put not applicable or none. Okay, good. Who are we on? Owen, how do we find the limit at infinities both?
Plug in infinity for x.
Oh, whoop, yep,
So infinity to the fourth would be the biggest number, so
everything else would be irrelevant.
everything else is
Perfect.
irrelevant. So the limit of x to infinity is infinity.
Good. How about negative infinity?
X to the fourth just completely takes it to infinity. Everything else is nullified, so limit of x to negative infinity is also infinity.
Perfect. So on a polynomial, we ignore all the lower degrees and this one's super quick. Okay, so in terms of pre-calc and algebra 2 wording, this would mean on the left our graph goes up, on the right our graph goes up. So I'm gonna go to my graph and draw those. Oh, that is the top of my graph. Awesome. Well, normally I would just have you draw an arrow going up. I guess I will make a mini one. That's how it's gonna go up on the left, up on the right. And I'm drawing them by those points because since this is a polynomial, it's gonna follow polynomial-ish shape. And the x-intercepts kind of determine how wide it's gonna be or anything like that. So I made those arrows near the points just because it's a polynomial. Normally, I'd put them on the ends. Okay, domain and range. Walter, domain?
All real numbers.
Yeah, you can put any number in place of that. Range, you generally do that after you graph it, which is kind of backwards. Because you're not really gonna know the range until you know what it looks like. So the range is kind of a strange one because there's not really a way to find it until you finish the problem. So this isn't really much of a help to graphing it, but hey, we'll figure it out. All right, so this is everything from the original function. Do I need anything up there? Can I erase it? I should be fine to erase that. Okay. Oh, wait, yeah. Does anybody need those answers up there yet?
Does that R mean like all real numbers?
All real.
Okay.
It's a capital R with a second line. Have you not had any teachers make that symbol?
Not in a few years.
Oh. I didn't even know there was another symbol for all those. Or did they just write negative infinity, infinity? Oh, okay. All right, Neil, what do we need to do next?
Find the derivative.
Yep, okay, what is that?
X cubed minus 36 x squared plus 96 x minus 64.
Good. Bert, what do we know?
What do we know?
What do we do now? Sorry.
Oh. Find the third numbers,
Okay,
so set it equals 0.
how'd you go about that? What's the first thing you always look for in any polynomial if you can?
Any factor.
If anything is in common. But you're correct with the factoring part, it's just, if something is in common, you take that out first because it always makes it smaller.
Yeah, you take out 4.
Yep. Yeah, there is no common letter, but the 4 will help you out quite a bit in terms of everything else. 24, I think. And I don't believe factor by grouping will work on this one either, because the ratios are off, so I'm gonna have to do synthetic division again. Okay, so I've got 1, -9, 24, -16. So numbers of 16, I guess at least there's a lot less choices. I'm thinking it's either gonna be 2 or 4, probably.
It's 4,
Oh, again, all right.
yeah.
So 1, 4, negative 5, negative 24, 16, 0. Okay, so we found out x minus 4 is a factor. And then the other factors are gonna come from 1x squared minus 5x plus 4. And that'll be minus 4 minus 1. I know I already erased this. Did you guys do multiplicities of factors in pre-calc? So like a single factor or 3 of the same factors or 5 of the same factors would go through the x-axis? And an even number would bounce off of it? All right, so I'm not really, I mean, that was pretty much the lesson, but, because this one had 3 factors at x minus 4 in the original function, so I know it's gonna go through, but if you had it squared, it would bounce off. Okay, so, Marvel, what does this tell us? How do you get your Chromebook?
It tells us, wait,
Yeah, I know, that was kind of what I was asking.
so you're trying to find the zero. Oh, okay, there's so many like critical numbers.
There is a lot of critical numbers. What are they?
4, 1, and
Seems like there should be a lot, but there's not.
okay.
So 2 of them are the same, the 4 in the beginning is nothing. Yep, so those are the only critical numbers that we're gonna use. Obviously, if 4 is listed twice, you don't need to list it twice. Okay. Ooh, I almost erased that, I need that yet. So critical numbers, next is increasing, decreasing. Marvel, you wanna pick somebody while I'm writing out all this stuff? What on earth? What do we do with that info, Sebastian?
Maybe like put it on the number line and find the slopes and distance.
Perfect. Okay, so we're gonna do the plus and minus number line table. So 1 and 4. And so 0 is a nice easy choice. 4 times negative times negative times negative would be a negative answer. 2. 4 times negative times positive would be positive answer. And then I'll plug in like 5 or 10. I'll do 10, that's easier. 10, 4 times positive times positive times positive. So I got negative, positive, positive. Did I do that right?
Yeah.
You guys got that too? Perfect. Okay, increasing is gonna be from 1 to 4. It doesn't increase at 4, it flattens out at 4. And then it increases from 4 to infinity. Decreasing from negative infinity to 1. Critical points.
How do you know it flattens out at 4? Instead of.
At 4, we have a slope of 0.
Okay.
So slope of 0 meaning flat. So I know that it flattens out at 1 and flattens out at 4.
Okay.
And that's what we're gonna draw next.
Thank you.
Yep. Did you already find the points?
No.
Oh, yeah,
I don't
question,
know how
okay,
to-
go ahead.
No, but I know how to do it.
Oh, well, did you want me to answer the question first?
No. Never mind.
Okay, and I'll just emphasize from yesterday, critical numbers and critical points are actually different answers. Critical numbers is usually just x values. Critical points are the actual points they would be. Now, you 100% can figure out a max and a min first if you want, but otherwise critical points are just the actual points you can put on the graph. So did anybody put those in yet?
I got 1 in negative 27.
Okay, that sounds right to me. And then 4 is, oh, 4 is 0, isn't it? I think 4 was a 0. That could be right. That was one of our, yeah, intercepts. Correct. To find points, it has to be in the original function. Okay, relative max. Well, I know we're going down, up, up. Whoops. So there is not a there's not a relative max. But there is a relative min at 1 because it goes from decreasing to increasing. So we have a relative min at 1, negative 27. Okay, unlike yesterday, this info gives us a lot to draw.
So for the relative max, it can't be at an endpoint, right?
There is no endpoint.
No. Okay.
Absolute max is, I think, maybe what you're thinking
Okay.
of. But you're right, a relative can't be at an endpoint. Anyway,
Okay, like if it stopped somewhere, like if it didn't go to negative infinity or whatever, if it went to like 0 and 0 was the highest part of the graph, but that was also where it ended, then there would be no max.
correct. Relative is only in between whatever you have.
An absolute could be on an endpoint.
Yes, but you're actually very seldom asked for an absolute, so. Okay, I'm gonna try to draw this. So, first thing, my critical numbers of 1 and 4, I found that they both had a slope of 0. They're not undefined slopes. So, at x equals 1 and x equals 4, I'm going to draw a little flat line of a slope of 0. At 1, negative 27, oh my goodness. 1, negative 27. Oh, I didn't go far enough. I thought it only went to 25. Well, that's annoying. Can I slide that? I cannot. I set it as my background. Awesome. I'm just going to draw it right there. But yours is at 1, negative 27. And at 4, 0, I'm going to also draw a little flat line because it flattens out at a slope of 0 there. Okay, so that was just the critical numbers. Increasing. So it's going to be going up from 1 to 4 and 4 to infinity. Okay? I'm going to zoom out. So I have a point that, what on earth? I know it is increasing from this red point right here. Wait, what? I think I tapped extend page maybe.
Yeah.
But, oh, all right, whatever. It is increasing from this point up to that point. So I'm just going to rough sketch a line going up. And then it is increasing. Now I wish I had a farther top. How come I don't extend the top? It is going to be increasing from this point pretty much right at the top. Right there. I think maybe for $6 I'll make a better graph. And then it was decreasing from negative infinity to 0? No, decreasing from negative infinity to 1, right? Okay, so it's going down, it has to go through that point. And then from 0 to 1, this is going to be an awfully steep line that I don't know if I can draw. Actually, I'm pretty impressed that that didn't come out a lot worse. But it's going down all the way to that point right there. What time do we get done? 6, yeah, we're definitely not finishing it, but we'll try. We might. Oop. Okay, let's see. Oh, relative min. A relative min means it is the bottom of something. So I'm just going to put a little curve there, even though I know that that's already kind of what it looks like. I think we graphed everything else already. Okay, so we've got a little graph so far. Now we are on the second derivative information. Second derivative, 12x squared minus 72x plus 96. Do I need to ask the same question? Like, do we know what to do, immediately do? So equal to 0, undefined, okay? I believe 12 goes into 72 and 86. Is that 8? Yeah, that's 96. Okay, so a 4 again. Oh my goodness. Okay. So we get 4 and 2 as hips. Those are possible inflection points, so those are x values. I should write x equals, I just running out of time and space. Marvin, what are you doing? Did you just switch from the Chromebook to the phone? What did I do? How did I zoom? I am. What is going on? I mean, I know I tap it with my shirt all the time, but I don't know how that does zoom. Okay, so possible inflection points. Next thing is where is it concave up and down? So we're trying to figure out curvature, so we have to make a number line with 2 and 4. And I'm gonna plug 0 into my factored one because that's a lot easier. Positive, negative, negative would be a positive concavity. If I plug 3 in, positive, negative, positive. If I plug in 10, positive, positive, positive. Do you guys know what I'm saying when I say positive, negative? Should I be clearer on that?
Yes.
Okay.
You got it.
Okay. It's like multiplying out those answers. So like I'm saying, a positive times a negative times a positive. Okay, so it is concave up from negative infinity to 2 and from 4 on. Concave down from 2 to 4. And then actual inflection points. I'm going to abbreviate that, I don't remember. It looks like both of them should be actual inflection points because it alternates everywhere. So we would have to plug 2 into the original function and 4 into the original function, which we've already done, to find out where it switches concavity. What is 2? Is that like negative? I know it's like negative 16. Okay, so that's all I need from second derivative. It does give me a little bit more to put on the graph. Like for 1, I have an inflection point at 2, negative 16, which I didn't have graphed before. So 2, negative 16, oh, look at that. Okay, now all that point does is it tells me where it changes curvature. And then there was another one at 4, 0. Basically everything's at 4, 0. It's going to be curving up from negative infinity all the way to there. Now we kind of already have that drawn, right? Like, that is curving upwards. If I could draw better, but. And then it is curving downwards from this inflection point to that inflection point. And so what I'm gonna do is I'm gonna follow my rough drawing, but I'm gonna draw it as curving down. Oh, it's so hard to draw. But I'm gonna draw it curving down. And then it is gonna be curving up from 4 on. And so I flattened out at 4, but now I'm gonna curve up.
So the first left side is just all straight down.
It is going all, well, it's not straight, but it is curving up very steeply.
Concave.
Yep. If you guys graph this on your, FYI, when I was trying to tell you if you want to do more examples, these are obviously the easiest to check on your own without an answer key because you just type it in your graphic calculator and see what it looks like. So if you guys graph this on something you have, it should look pretty much exactly like this. I say exactly like this, but I guess you would have to kind of make your window about the same to make it look the same proportion. But otherwise, that's gonna be pretty accurate. If this were a test, everything I did here would be really lightly, and then I would do shade darker. No, I kinda had a feeling that I would not get everything in today that I wanted, 'cause if nothing, this problem just takes a long time. Perfect.
Weren't you gonna go over how to like read?
That's what I was literally just talking about.
Oh, okay, I'm sorry.
Yeah, that's
I
okay.
was explaining some of the specs I didn't do.
Yeah, I didn't think I was gonna finish everything today that we wanted to, cause I knew this was gonna take a while, so tomorrow I'll definitely do that problem from the packet. That's how to draw a function from constraints. And that'll probably take the first part of the hour, and then I'll start 5-6 after that. I don't know if I'll take the whole hour to do this, but I guess I could, depending on how much you're struggling on. Like, how's the homework been so far?
Slow.
Extremely slow.
I think it's
Yeah.
slow, but it's not like that hard, like it's pretty much just the same.
Yeah, it takes
thing.
forever to find all the answers, yeah, for sure. Okay, otherwise, like I said, I'll ask you tomorrow if you want me to help you with anything from the homework. Otherwise, I'll do that last little part of the homework question.